Take out this sheet of paper I gave to about half of you. It says Teacher Master HH.
It's Ben.
This is where we left off last time as we started talking about atoms. So about half of you had this sheet of paper. You got a partner that you're dealing with? Should Chloe have this one? Can you grab that right here? Take a look. Did you have it? Step on, can you get it? Oh, you got it. Thank you. Alright, so let's take a look at this. What does this stuff all mean? How many different elements are on the periodic table of elements? I think you said it yesterday, yeah? 118, but not all of those were found on Earth, right? Some of them were kind of put together. So up at the top of this page, if you're looking at with your partner, it shows 90. Because there are 90 elements out of that 118 periodic table that are actually found on Earth. And that means they are made up of 90 different atoms. Okay? Atoms, remember, are like the smallest parts of an element. Thank you. Okay, so atoms can combine to make new substances. We talked about that a little bit yesterday. We talked about that kind of before as well. So you could have a couple of the same type of atoms. So maybe you've got two oxygen atoms that go together. And if they're the same kind, that would be an element. Right? If you have 5 of them, 7 of them, 12 of them, as long as they're all the same kind, you could say that that is oxygen element. Hydrogen, 2 of them, 4 of them, 12 of them, whatever. That would be an element. However, if you take different atoms, and that's what you're seeing over here, atoms combining together with other atoms, maybe I've got 2 oxygen and a carbon that are stuck together. That's no longer an element, right? We're not going to find that on the periodic table of elements because it's a mixture of them. And so we call those compounds. And we've dealt with a bunch of compounds before, such as NaCl. What is that?
Sodium chloride?
Yeah. And what's the common name for sodium chloride? I like it on my fries. I like it in my soup. I like it a little bit too much on most of the stuff. I eat a lot of salt. It's not good for you if you have too much of it, right? Mm-hmm. Okay, so depending on how these atoms are mixed together, they might remain an element if they're all the same kind, or they might be a compound. Make sense? And now we take a step further than that. Now we're saying, depending on how closely connected, how strong the bond is between these things, we might call them molecules. So if you have a very strong connection, whether it's the same kind, so like here pictured we've got 2 hydrogen. If it's a very strong bond of 2 hydrogen, we would call it a hydrogen molecule. Is it still an element? Sure, because it's the same kind. Okay, maybe it's a mixture of them, oxygen and carbon, but if it's a very strong bond, now we call it a molecular compound. Molecular basically just means it's strongly bonded. If it doesn't have a strong bond, if they are connected but it's not a very strong bond, we would call it ionic. Make sense? So basically a bunch of vocabulary that explains how these atoms either go together and how strongly connected they are. All right, I want you to take 2 minutes to basically just walk through the same thing that we just did to talk about atoms, elements, compounds, molecules, and ionic compounds. Ready, set, go. Are you done with that?
Okay. Mr. Partner.
Strong bond are called molecular.
John Goldman molecule. You know that. Which one? Compound. Did you know that? So, what is mine has both. Or just ask me.
30 more seconds.
How about you? Partner. Quote unquote. It's raining tacos.
No.
Okay, take a seat. Questions on any of that? That's the basics of it? Alright. So now, we had looked at this yesterday. We've got these different colored dots. What do you think blue represents with a big H on it? Shout it out.
Hydrogen.
The orange C is? Nope. Carbon. Okay, so we got hydrogen, carbon. Red O is?
Oxygen.
Green Cl is? Chlorine. And Na?
Sodium.
Sodium. Okay. So we're going to use those same items here. And we could take a couple of these and put them together. So for example, if I had, we did this already yesterday, if I had not just one but two of these blue H's, and I said, well, I can take both of those and I can combine them with one oxygen. What do I have? Trevor? Water, because it's called H2O. Now, some people, when they draw them or put them together as a representation, what's happening at a microscopic level, sometimes people will draw them like this. Here's an H, here's an H, here's an O, and then they just kind of connect them with these little lines. That's the way I've learned it, and I think most of the time that's the way our textbook is going to show it. You might also see it elsewhere, where they're just circles that are touching like that, which is okay. Sometimes you might even see it where there's kind of circles that are like overlapping to show that there's a connection between them. So one's not more right than the other. When I draw them, I'll probably draw them with that little dash in between. Okay. So what I would like you guys to do now is you're going to be given a handful of hydrogen, oxygen, carbon, chlorine, sodium, little dot stickers. Okay, and I've got them laid out for you. Maya sorted them out for us this morning into different cups. So if you guys on this side can go back and get one cup, and each cup has a bunch of little stickers, go ahead and do that. We'll let your group go first. Grab one cup, take it back. You two. Oh, I'm sorry. Each individual can get one. We should have enough for everybody to have their own. Second row, Enya's row can go and get it. Okay, Amaya, your group can go get it. And then Tori and Tyler, you can too. Alright, so what we are going to do with all of these little dots, first of all, you're going to label them with the proper letters. So if you've got, can I borrow yours for a second? Thank you. So everybody's got these little dots. All these little red dots match the red oxygen dot that I've got on board. So put a little O on that. All the yellow ones add an Na. All the green ones add a Cl. All the blue ones add an H for hydrogen. Can everybody see these? Put them up here a little bit better. Okay, so that way we're using the same colors to represent the same types of molecules. And while you're doing that, I'm going to come around and I'm going to pass out this half sheet of paper, which has a number of the different elements, or I shouldn't say elements, a number of different compounds that we've used before. like carbon, water, carbon dioxide, sodium chloride, oxygen, sodium carbonate. And it's got the chemical formula there. And all of these are basic enough that they're using these 5 atoms. And we're going to actually construct what these compounds might look like at the atom level. The label of how these read, got a little hole on them. I need a pen, I don't know if pencil will work. All the yellow ones have the NA, just like I've got up on board.
Well, I put CL on that.
Uh-oh, we didn't get any greens? Amaya, you had 1 job. Well, you kind of had 5 jobs. How many greens? I forgot how many greens I needed everybody to have.
I have 1.
1?
I have 0 green.
Alright, we'll come around and get you green as well.
I need to eat my greens.
What we are going to do though is take the half sheet of paper and you're going to put those stickers on in that middle column in a way that represents what the molecule would look like if it's got those different atoms bonded together. And then we'll also look in the 4th and 5th columns to recognize how many total elements are in the compound and how many atoms specifically are in the compound. Okay, so that's what we're going to do right now.